I take this lovely dime. Devin, do you agree that there's a heads, heads, and a tails? Oh, just let it go, Devin. All right. Well, let it go, okay? I can't hold it back anymore. He was frozen. Let it go. I can't hold it back anymore. All right. Anyway, so I take this dime. What's the probability I flip the coin and it's heads? 50%. I lost. It was tails. Now, what's the probability I flip heads again? Did that flip have any bearing upon what I did prior to it? No. It was an independent event. So every time you flip a coin, it's its own event. So you can do compounding probabilities off of that idea. Ready? I was trying to set it aside so I didn't have to do it. Can I show you guys how to do this? Really? Sorry, this is way too close. That was way too close. Here we go. Oh, there it is. Yeah, you take it, you take it, you take it, pennies and nickels are the best. Put it in your pocket, your sack. You guys don't do that? Oh, you know why? You guys didn't grow up when you had these things called payphones, where you had to use a quarter or something to call a parent to pick you up. So now you just, if you get it going, it makes a really cool sound. Why, hello, Reagan. What's up? Thanks. Hey, you can go get your stuff early now. You're welcome. No. Anyway, so over here, ready? I'm not going to snap it at you, but thank you. So you get these things called independent events. So the probability of going and getting tails, tails, tails in three successive flips means that you're just multiplying the probabilities together because each one of these trials, what we call it, is independent. There is no bearing upon the fact of each successive trial. So I flip a coin. Every time I flip a coin, that probability is still going to be one half its heads, one half its tails. That doesn't change. What's different when you have these dependent things is just it's how it's worded. Okay, it's going to be how things are worded. Another really, really easy example. No. We have this giant spinning wheel of awesomeness. Sorry, I forgot to erase something on it. So the giant spinning wheel of awesomeness spins around and around it goes. Where it stops, nobody knows. Don't argue with me on this. I know. So you're playing this game that involves spinning the money wheel. Yay! So what's the probability you get more than $500 in your first spin and then you go bankrupt on your second? Does the second spin have any bearing upon what happened in the first spin? Not at all. So all you have to do, but between the spins, it doesn't matter. So all you got to do then is just count how many of them are more than $500, and we get, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 of them, I think there's 24. Was it 24? 8 out of 24 for your first trial. And then how many bankrupts are there? 2. And you're multiplying between them because each spin is its own independent event. Okay? Does that make sense? It's very simple how to make that work, and you probably would have been able to figure that out on your own without too much of a hassle. Because we've done independent events, or sorry, we've done some of the independent stuff already by just multiplying up some of our probabilities. Right? What changes then is if you have the dependent. Dependent goes along with a lot of times with the vocabulary of what's called with or without replacement. For example, if I take a deck of cards and I shuffle it, and what's the probability that we get the right card at the time? So what's the probability you're going to guess the correct card? 1 out of 52. What is it? Wrong. So it's 7 of diamonds. So the probability that you're just going to get this card correctly was 1 out of 52. Now, if I leave this card out of the deck, what's the probability she gets the card correctly now? Now, is that dependent or independent? It's dependent because I left this one out. It changed. If I put this back in with replacement, then it would be independent. So, all right, now what is it, Jordan? So let's talk to our card shark up front here. Now, independent, dependent. It's red. And so on. So when you're talking about dependent and independent, you're looking at this thing called. Oh, I'll go back. I'll come back to that one. Just I got out of sequence here. I saved the wrong file today, so I'm sorry. So we're looking at picking a card. Let's think of this one. What's the probability that we pick a face card first, and then a 7 of hearts? We'll do it with replacement, and then we'll do it without replacement. So with replacement generally stands for, is that going to be independent or dependent? It's going to be independent, okay? So we're looking at the idea that we're going to go and we'll probably get a face card first and then a 7 of hearts. We'll do it 2 different ways, with replacement, without replacement. So the probability that we get a face card first is out of how many? Oh. Yeah, how many face cards are there? There's 12. Remember, face cards are jack, kings, and queens, and there's 4 of each. It's okay. So there's 12 face cards. So you got 12 out of 52, and then if I pick that one card and I put it back in the deck, how many possible ways can I get a 7 of hearts? And that's what you would do. So let's see how we did. Wah, wah, wah. Wah, wah, wah. This is why gambling is not good. All right. Now, what changes if I do without replacement? Does the first probability change? No. It's still 12 out of 52. I don't put that card back. How many cards do I have to choose from? 51. What you're saying is that there's a better chance. All right, so let's see if we do it. Ready, Maggie? Womp womp. Womp womp. It's the same two cards I just picked, isn't it? No, I shuffled. I did. Seriously, I did. We added, let's say if you wanted to do, what's the probability of getting a queen or a 6? Well, that's a good way of thinking it. This also goes with the, your textbook. Your textbook uses this terminology, the probability of A and B, face card, and a 7 of hearts. They write it as probability of getting the face card times the probability of getting the hearts such that you have already gotten an ace. This B vertical line A, that means probability of B such that A has occurred. That means it's a dependent event when you see that vertical line. It's not that you have to use the formula. I'm pretty sure I skip over the line, solve the equation stuff with this. To be honest with you, a lot. Just it's really worry about it. I like using just the straight word stuff. This also works when you're trying to do when we did our first example with lottery. Remember our first example with lottery? Is lottery an independent or a dependent event? It's dependent because those ping pong balls don't go back in the hopper. Okay? The ping pong balls don't go back in the hopper. So you've got 1 out of 56 or whatever it was, and you just keep working your way down. I think I had that one in here. Oh, here we go. This one. Oh, we just did this one. Never mind. So we do. So the idea of picking 6 lotto numbers. I'm thinking nowadays in just the regular lottery, there's 56 numbers. If you're going to correctly guess the 6 numbers in a lottery, does the order in which you guess them matter? It doesn't. It doesn't. It's just a lot of times if your numbers are 1, 2, 3, 4, 5, 6, and they come up 6, 5, 4, 3, 2, 1, you still win. Okay. The order in which they were selected doesn't have a bearing upon it. So, what's the probability you're going to get the first number correct if there's 56 ping pong balls in it? 1 out of 56. That ping pong ball does not go back into the hopper, which means what's the probability of the next one? And so on. So remember when we did this problem not too long ago? That's what it was. That's why Judkins was able to guess the correct card towards the end because there were less to choose from. Oh, well, he's just not good at guessing. Womp, womp. Well, he was just too much on the spot, like, oh, it's gonna be, it's It's a fairly accurate impersonation. Oh, I didn't hear you. I thought you just kind of looked at me like, what? Oh. Usually I'm just getting like, so like Brony and Boney. I guess really the only weird thing that comes out of this is table stuff. This is so simple. You can do this. I'm not worried about it. So, yeah, there's not much to this. I don't think it was all of this. I think it just goes through 25. Yeah, just go through 25. We're not going to worry about the other ones. Some of the other ones dealt with combinations with this. I am going to stay away, guys. I'm going to stay away from combinations with the probability of independent-dependent events, it just gets nasty. Okay. Also, we're going to test on this Friday. Bless you. Tomorrow, what we're going to do is we're going to do normal curve stuff. Here, you can be there. How many passes I just saved one from there? Identity theft. Quick, hide your stuff. What we're gonna do tomorrow, because I think there's a couple people that were. Is there another AP? Oh, you guys will be back by AP then. Okay. The stuff that we're looking at tomorrow is the normal curve.
Yeah, we'll be back.
Oh, you'll be back on Friday?
Yeah, we get back.
How many of you guys are gone on that? Oh, that sucks. We might have to go Monday then. Wait, how many of you guys are gone on Friday? How many of you are gone on Friday? And is there a test in the morning that day too? What test is that morning? So I'm going to lose a lot of people first hour too, aren't I? Audience, see that? Did you not know that there was an AP test on Monday? Friday? Man, if there's only this thing called a calendar that you can keep up with. I'll figure it out on the first hour. Oh, thank you. We might have to go Monday just because I don't want to. Because half of you guys would be out taking the test anyway, so it would just be you can recycle it. So it'll work from there. Well, if that's the case, then hey guys, if that's what it works out, then we might be able to do 12-6, and then we can do 12-7 on Thursday, and then we can do a bunch of review chunk on Friday, and then make the test then on Monday. I think we'll probably be able to do that. I hate to do it Monday, but if over half of you will be gone, then it would just be a wasted day on Monday anyway. So I really don't need to stretch probability for a whole nother 7 days. I mean, I could try. We can just keep playing blackjack. But I got like $6. All right. So Devin, I'll figure it out when I talk to first hour tomorrow about if we're gonna be able to. If we have so many people missing on Friday for AP testing, so we might have to move. I'll probably have to move the test until Monday, but we'll figure out if first hour is also missing a whole bunch of Friday morning. I guess it'll probably be Monday now, and then we'll just add an extra section in. Okay. Okay. Sir. Yeah, hey guys, real quick on those problems, I realized from earlier today that some of them are difficult to tell whether or not they are green or blue. So let me show you real quick. Does that help? You've got your. Woo! There are 4 green, 4 blue, 5 yellow, and 3 red. Does that help? You have to leave now too? Naughty child. Such a bad person. You should be. Have a good one. We'll see you tomorrow. Whatever. Pass on the